Hi everyone. So this is one of the most awaited events. So this is the first experience from my side coming onto the stage. Most of the time I was on background. So all that particular talk that we are having here, I will try to provide some insights from what I have learned. And I also give you a picture about how thinking differently can change even if you're taking a baby step. So most of the talks till now would have seen about me, but we know that, right? If you go alone, it is race. If you go as a team, it sets the pace. So I just want to introduce my team, which is SAP Innovation Center Network. And what do? We have fun. What kind of fun? So our task is, can you future-proof SAP? So day in and day out, there are only two tasks. Whatever is the modality of data, let it be text, speech, image, video, time series, it doesn't really matter. And now a buzzword called metaverse also has come in, where a lot of people doesn't even know which tool works where. So our job is to make sure how we can future-proof SAP by taking all the data that we have, the enterprise data from SAP, and provide insights to our customers. And the most important thing that what do we do is not restricted to thinking out of the box, throw the box itself. There is no limit to it. Can you think out of the world? So these are the two metrics on which we work as a team and have fun. So let me show you a brief thing about what kind of work that we do. Going to the next slide, let's go to the agenda of the talk. Let's get into a realm of self-supervised learning. So all the agenda is only 3 items. Need for self-supervised learning, that is the information that you get on internet or conferences or different blog posts or multiple other resources as well, GitHub and all that. The second thing is, what is the problem that I tried to solve? It could be a small problem, doesn't matter. But what are the problem that I had opportunity to work with at SAP? And the third thing is combining the information from internet and also from the practice. What are the learnings? And we know that, right? Learnings are for yourself. That is why it is called self-learning. And this particular material is not found on internet. But this statement is false tomorrow because you have this recording from tomorrow. So let's go to the first section, need for self-supervised learning. So I have done PhD in computer vision where we were looking at different problems like image classification, and on a image net data, it shows you 80%, but on a real world data, it shows 30%. Or let it take automatic image captioning. There are so good kind of algorithms that are already there, which actually tells you, hey, left image is a pot of broccoli on the stove. And see the right, how smart it is. A group of people posing for the picture. It's not even saying picture, right? So that kind of smart algorithms are there. And for each slide, let's say I have given courtesy at the leftmost corner. The other thing is, look at this. It says a car parked on the side of the road. Take this real world image. It still says a car parked on the side of the road. What is the problem? The problem is we are trying to use supervised learning. We are fixing the task as image captioning and trying to learn the network, and the network learns only image captioning. It never learned the car. It never learned the road. It never learned what is parking. It never learned what is side. Let's take an example in video, action recognition in video. So there are set of 4 frames which says opening the fridge, pick up the cup, or slicing the bread, opening the fridge. The third step says, yes, you have opening the fridge, but actually the fridge is open. So now there is an issue with respect to the supervised learning as well. It doesn't come with it doesn't come easily, right? ImageNet or maybe Coco image captioning, you have 1,20,000 images, just a rough cut of 15 cents per sentence. Somebody is trying to label it. Somebody has to sit and actually maybe an Amazon Turk, or it could be given to set of users who are volunteering. The instructions are given: A, describe all the important points of the screen. Do not start with the sentence "there is." So naturally, the particular captioning is not happening. You put the constraint: don't start with this. Don't describe unimportant details. How do you know what is important, what is unimportant? Okay. With that constraint, they have described the image, and that we are using it as a label and learning the data. So you get it? It's all constraint environment. And if you look at the fifth point here, do not give proper people proper names. The sentence should contain at least 8 words. Come on. You're giving it a user and asking, describe all the important parts. And you're saying, don't describe all. Don't do that. Don't do this. Don't do that. So the moment the entirety is gone, we get into the problem of only the subset of things that we are looking at. So why not? So in one sentence, I want to say the AI revolution will not be supervised. That's what Alexei Afros, whom I have a lot of respect, because most of the things that I have understood is from his slides. So this is given by ICML 2019. So now if he is saying AI revolution will not be supervised, this is from academia. Is there somebody helping from the industry? There it is. You have Jan LeCun, who is from Facebook. He comes and says, boss, if you think that this is a cake, the reinforcement learning is a cherry. The supervised learning is the icing, but the self-supervised learning is the cake itself. So he spoke in AAAI 2020 talk. This particular slide was given. And that's where I started thinking, people are running behind reinforcement learning with that. Fine, it's good. You are trying to solve a lot of these problems. But a few bits for some samples. You are looking at supervised learning where you're trying to predict human supplied data, right? You are just predicting a category or few number of each inputs. But I need the cake, because we don't, suppose you don't like cherry, you throw it. You don't like icing, somebody has sugar, he doesn't eat it. But everybody likes the cake, right? But the problem is, which is the flavor that you need is self-supervised learning. Okay, so in academia, there is this nice setup that is given saying that you decouple the task of learning, that is called the downstream task. You decouple from what it is learning. So there is a pre-test task that is like a general task. First you learn it, and then you do a knowledge transfer of copying these weights into this particular network. And now you fine tune for that particular downstream task. What is an example of a pre-test task? Take the example of BERT. What does it do? It just do masked language representation or next sentence kind of thing. On that it learns. After that you do question and answering or any of the things that you want. That is your downstream task. Is it the new name for transfer learning? No, both have different contexts. In transfer learning, still your target is same. Previously, maybe you used to have 5 categories. You're looking at 10 categories for your data. Or you're looking at 1,000 categories in the ImageNet. You're looking at maybe 2 categories in your data. But the task is same. But in the self-supervised learning, the pre-test tasks that you are doing versus the downstream tasks, it could be completely different. Okay, let's not get into text. Text is boring, right? Image speaks 1,000 words. Oh, videos, I don't know how many words it speaks. So how we can define? So a lot of people are getting into detail. So we don't have time. Let's get into the images. At least 1,000 words, let's pick. So the first kind of algorithm that I learned in self-supervision from the image is autoencoder. Such a powerful concept where you have the data and you're trying to predict the data itself. So let's say I have given an image, I add noise I take the noise image as my input and the real image which was there before give as an output and learn a network. Over a period of time, this network learns to remove noise and give you the right data. Now, this particular arm is called the encoder arm. You are trying to encode the representation of this particular data. Now, this might have smaller dimension. So you can think of autoencoder as dimensionality reduction problem. So let's say it need not be image. Let's say I have 10,000 dimensions of data. You try to figure out what is this particular thing that you want to do automatically, right? Now I need only 10 dimension of that data. Run an autoencoder. Pick which layer you want, right? Mostly in the encoding so that you get the representation and you have the mirror that will actually your decoder. So this is one thing you can think of autoencoder as self-supervision as data compression. Similarly, you can look at partial taxonomy. You have data prediction as your task. You run through the network and actually get the data. Or you have two data points. I'm learning the transformation itself. Or I even doesn't know what I want to do, but I just want to see how do I impose constraints on the data. So this particular partial taxonomy actually helped in coming with different particular use cases. Now look at this. I have an image, break the image diagonally, take the upper part of the image, down part, whatever you want to fill, run it. The down part, you give it as what you want to predict, right? Then you use any kind of loss that you need. Now you have learned how do you fill the data prediction. This is called the missing data prediction. Okay, this is one of the most fascinating thing that I saw. So somebody came and said, hey, you're taking only one image and trying to do. Why don't I take two images? Fine. Take two images of same class, learn the representation. Use any kind of network that you want. You know that, let's say I take part of dog and part of dog, right? I know that they attract. Now, if I take part of the dog and take a part of the chair, it repel. So just learn 1 to attract, 0 to repel. At the end of it, this particular CNN that you have, it actually learned, given two images, do they belong to same class or not? So powerful. And this particular paradigm is called contrastive learning. Now, there are multiple other things as well. Decolorization in painting. So in my MTech, the first project that I have done was on image in painting. But when this deep learning came, it just rocked everything, right? Previously, it used to be feature descriptors. You need to find out for this particular task, whether to use LBP, local binary pattern, or you want to use maybe Weber local descriptor, multiple shift, surf, HOG, histogram of gradients. We used to do all that, but now it is all about I can automatically learn the representation. So for example, you have the image, you jumble the image, break the image into 9 parts, you jumble the image, learn, you know, okay, this is 1, this is 2, this is 3, whatever, that particular order, learn the order. So you will know, given a jumbled image, how do I put this? You can think of like jigsaw puzzle. So let's not get into too many little details, but what I wanted to say is self-supervision actually revolutionized a lot of things in vision. Now let's come to NLP. I talked about BERT. It could be GPT or multiple other things. The main particular fundamental block is your transformer or self-attention. So what is attention? There is a lot of noise around. Can I focus on the source than the noise? Can I focus on the noise? Or do I need to focus on the voice? That is attention. Self means you're not giving any label on top. You're trying to learn automatically. Such an intelligent agent. It polls after every time. I said I was in Asia. I need to tell it every moment. That's fine. Okay. Coming to BERT, as I told you, you just have two things. Mask language model. Language model means predicting the next word, right? Now you do your pre-training. There are only two tasks. take 2 pairs, predict the next sentence, or you take 15% kind of mask and now try to randomly predict that mask, right? Now the problem is this is a bidirectional. So you have to be very careful there. Because it is bidirectional, you can end up the target being exposed to the input as well as the input being exposed to the target. That's why you do it randomly with that particular percentage, right? And Jalamar nicely illustrates the BERT as well. The link is given below. Now, once this particular BERT is learned, now you have self-supervision in action. You can do multiple other things. You can do your question answering. You can do NER. You can do multiple other things as well. So the pre-test task is your mask sentence and predicting the next sentence. Mask LM and predicting the next sentence. While your downstream task is question answer pair or question pair or automate captioning, multiple other things that you want to put there. So this might be too overwhelming, but I just want to say there is a lot of traction that happened in 2020 once this BERT came out and people started coming up with their own thing. Robotas, Google came up with something else, UNC came up with something else. It's all new versions of different tasks, different pre-test tasks, different downstream tasks, adding constraints on top, right? And you could look at downstream task as visual entitlement, image captioning, referring expressions, or below you could look at it as video captioning, video and language inference, and all that. But the sum and substance I want to say is self-supervision actually revolutionized NLP as well. Now let's coming to, we have seen a lot of images. Let's go to practice. So fine, you have learned multiple papers, you have done whatever you want to do under the sun, but when you come to work, it's what is the project that is given to you, and see what kind of value add that you could contribute based on the knowledge that you have gained in the need for self-supervision. So the first project that I got exposed is Sound AI. So the premise is, can we use airborne sound as an additional source of information? All I used was just autoencoder. So there were other attempts also were made. So we are waiting for the customer to come in. We are trying to collaborate with academic institution for sound processing. There are multiple clients that are ready to pilot. We have decentralized distributed learning setup ready. MLOps we are trying to envision. Let's see where it goes. The second project that I worked on is NLP to HANA. So HANA is one of the major product for SAP, right? So there are two major products. One is your analytics library, and there is this BTP, which is your business technology platform. These two form the crux. Analytics, think of it like it's the backbone churning what you need. You have all the algorithms that you see under the planet there. It might take some time to get into that, but the transformation has started. Now, NLP to HANA, you can visualize it as NLP to SQL that you had seen, right? Given an English sentence, can I give a query? So let's say there is a business user who comes. He doesn't even know whether to query it in SQL, whether you want to do it in maybe other databases. Multiple other databases are there, right? So column database, you can think of multiple other things, right? Now, all we need to do is, given a business sentence, can I actually come up with an SQL query? So that's the premise. I tried to paint a picture. Let's see how nice it is. So input is business statements. You have table and view structure. You have SQL query. Those are things that are available. For the input, you have aliases names for columns. You have sample ways for some defined columns. You have data type. What do you need? You have set of statements. You have SQL query. And we are looking at few short learning. You just give 5 examples. That's the beauty about self-supervised learning. You are now trying to learn the generalization capability. We are not at there. Maybe I'll talk about in the learnings or insights section. But for now, we need to do our job, right? Given set of business statements, I have to generate SQL query. Simple. Take a language model which gives you next word, sequence to sequence transformer models. Fix those examples which will do your few shot learning. Now the problem with GPT or any of these things, the context cannot be more than 2048, at least in Google Colab. Now try to find out how can I increase the context to 2048, more than 2048, right? Because now I give 5 examples, it might cross this. I want to give 100 examples because I want to generalize it on multiple other things. Can I do it? Maybe now the new things would have come, but it took a lot of time to figure out how to increase the context more than 2048. The most important thing is how can I generate the local context relevant to the query business statement? And at the end, it's few shot learning on local context to create SQL statement. This is just a proposition, right? Now you pick multiple other steps, try to find a new algorithm and see whether it works or not. At the end, the business should be interested to see, is it realizable on the production system? Okay, let's not get into details. So this is one more thing that we tried to work on. Forget it's, so you have, let's say a big paragraph. Can I summarize it, right? Given an whatever kind of context that you're looking for. Let's get into the most important part and the most awaiting part that I wanted to convey to people, right? Till now, whatever you have told, the first section, it's available on internet. The second section is available across SAP because it's internal and all the projects are there. Now, what is our stake? Or now, what is my stake? Okay, my contribution is very simple. I try to do my job sincerely and let's see how my learnings are. I just have only 2 points. So different people with different capabilities and different understandings of this deep learning could interpret my sentences in multiple ways, but that's the fun of it, right? I would call the loudest in the network is the weakest. Why? Take a meeting example. The guy who knows all his stuff keeps silent and waits for the right time or when he is asked for, correct? Similarly, what is the loudest in the deep learning network? Let's say all the layers may or may not participate because you can use skip connections to get rid of few of the layers for each of the samples, or even in a layer, I can do my, you do that, right? 40% off and those things doesn't work. So some of all the intermediate steps may or may not contribute to the most. They are, think of it like they are silent features, but they are talking about the representations, right? Whether the first layer, the second layer, the third layer, what kind of importance that it gets. We have a lot of papers called GradCam, GradCam++. By the way, GradCam++ is from my senior at my college. Okay, so now the target variable is always the loudest in deep neural network. Why? No matter whether the intermediate participate or not, at the end you have to reach the target, use it as a loss function, do the back prop, right? Or you could do what is the performance metric on this particular thing, change the target value. So the loudest part in my deep learning network is the target value. And we know we need to silence it. That is where self-supervision comes in. The target value is not available in self-supervision. The data, the learnings are from the data itself. Okay, come to the second part, the fun of it. So today we at our lunch, one of my colleague actually talked about, hey, somebody did PhD in Turkey and he said he wrote a nice paper called Somebody's Noise is Somebody's Data. I said, hey, that's what we're doing here, right? Go to internet, you have a lot of noise. Why I will call noise is slowly over a period of time, you get to know what to pick for you, right? That's why I call it noise. It's not that Don't take it literally. What I'm saying is all the information that is not required to me is noise. All the information that is required to me is voice. So can I extract what I need from what all I have, right? Now, pretest task is one mechanism, but the problem is still it is tied up to the task. So can I creatively design and cater to multiple use cases? Come to the second one. As I told, there is a lot of noise. Focus is important. So my manager was talking about, hey, Sai, you are like a child. You wander everywhere. Coming to the production system, you need to have focus. Okay, come on, let's have focus. And that particular statement led to this talk. And I give entire credit to my team, especially my manager, to making this particular task possible. So focused on what we need is self and not what we want is task specific or pleasing some other performance metric and all that. Okay. Now the thing is, you have talked quite a more. Where did you get this information from? I filtered voice from the noise, and these are the top 3 picks that I liked it. The second one, I had a picture, but I didn't have time to fix it. It's a super picture in the last slide. Thank you. The first point is about from Meta AI in terms of how they are using self-supervised learning at Facebook. Now it is called Meta. And I was talking about Jan, right? He was leading the effort. But doesn't matter who leads the effort. But he actually picked up something called the dark matter of intelligence. And it's not that easy. He's able to see something that most of the people are not able to see. So the first sentence or the one sentence that I liked in that particular work of his was self-supervision is one step on the path to human intelligence. But there are surely many steps that lie behind this one. Long-term progress will be cumulative. That is what is happening currently. Long-term progress is happening and it has to be cumulative, right? Because at the end, we are going for AGI. So it's all accumulation of multiple modalities. It's accumulation of multiple different tasks. It's accumulation of, we never know what is in store for us. Coming to the third point, self-supervised learning is a key to human level intelligence. I like this work where he just talks about, so most of the time we are talking about presence of it. Now we are talking about presence of something that can be a barrier. And what is the presence? Uncertainty. And we know uncertainty is the major barrier standing in the way of self-supervised learning success. What is uncertain? Paint your own picture. I painted mine. Thank you. I'm open for any questions till 8 p.m. I tried to answer with whatever kind of insights that I learned with. What is the difference between self-supervised learning and unsupervised learning? Self-supervised learning is part of unsupervised learning. It's not different. Unsupervised learning is where you don't have the label. In self-supervised learning, the label is coming from the data itself. I won't call it label. I would call it the data is forming a way to self-supervise itself. So self-supervised learning, think of it like is a unit case of unsupervised learning setup. The second question, are there any measures to calculate trade-off between computation cost and use case needs? I didn't understand this. Okay, let's maybe read it again. Are there any measures to calculate trade-off between computation cost and use case needs? There is no trade-off, right? Because computation cost comes up with use case needs. So somebody needs that use case, you better pay for it. What is the measure that you want? It depends on the performance. Okay, what is AGI? It's just a theoretical concept. They call it artificial general intelligence. still people are trying to figure out. And at least I don't have what is the vision for AGI, though there are few clusters here and there. But the thing is, can I have general intelligence? But the problem I did not understand is, if general intelligence is there, why is artificial coming into picture? Maybe I'll give an example. Most of the time, we are looking at the child sees only 2 examples and learns, and they call it 2-shot learning, or it doesn't learn, it learns by itself and called 0-shot learning. But look at the other way. The examples are shown only once or twice in the life. The child learns by itself maybe 23 hours, 59 minutes. Maybe for that 1 minute, he has seen an example. We are focusing on that 1 minute and creating the picture on top. We need to see how he has self-supervised and learned things by himself, not asking things to others. There is a lot of scope. I have maybe little bit of visibility. That's where I'm actually trying to put my thoughts together and trying to come up with some. Let's see. I'm still not clear. Maybe when things are clear, we could come up with something. So how ERP in SAP are developed into AI projects? So ERP is enterprise resource planning, are developed into AI projects. No. It's the other way. You take each line of business that is there at SAP and look at 2 things. One is, can I have AI adoption to make sure that you are looking at the top-notch kind of technology getting into the current system? And the second thing is finding the gaps using AI to make it smart. And the third thing is providing resources in terms of giving infrastructure using HANA, BTP, so that the customers' production systems are realizable. So day before yesterday, my manager took me to his CEO's cherry-picked boy, Max Wessel. And he said only one thing: we have huge vision for SAP, and most important one that we have is LOB adoption. And at SAP, we are taking it very seriously to make sure LOB adoption is happening, and all the effort are focused towards that. What is few shot learning? So few shot learning is, you have only few examples with you, and using that, you're trying to fine tune the existing pre-trained model to learn what you wanted to learn. Self-supervised learning is predictive learning. I showed you an example. It could be predictive, it could be data compression, it could be multiple other things. Maybe you missed the first part. Okay, can you please show QR code once again? Hey, don't worry. You have the YouTube link available there, or take it. Okay. Can we call reinforcement learning also a type of self-supervised learning? Because AlphaGo says it has learned to play itself by playing many times and getting feedbacks. Boss, anonymous attendee, I don't know who it is, at 7:41 p.m. You are looking at the cherry of the cake. This talk, we are talking about the cake. Okay. What is BERT? You're talking earlier. So BERT stands for bidirectional encoding, right? Bidirectional encoder, representative, whatever. It doesn't really matter. T for transformers, right? Now, what it did was, it basically, so previously you take the NLP, right? Now that this particular thing came, so I was thinking, why did I not cover NLP? So now this particular question could cover the NLP as well. So starting, you had word to vec, you have glove. In the word to vec also, you have 2 different things, right? On top of that, previously you had TF-IDF. But the problem was, all these are unidirectional. So take word to vec, it's unidirectional. BERT is bidirectional. I can go this side, I can go this side. Okay. Is GAN related to self-supervised learning? Oh, you're giving tough. I like it. So GAN is basically trying to do generative. Like you have two things, right? You have generator, you have discriminator. Now one can think of, once you train your GAN, the generator is giving you what you need, correct? So suppose in suppose I have example of class A and class B, and I want to learn about class A. I can give all the examples to GAN and learn the representation for GAN, so that generative knows exactly the distribution of that particular class A, and you can do augmentation and all that, making sure distribution is preserved. Similarly, coming to the decoder, it actually tries to see which is fake, which is generated. At the end, it learns given to exam. So most of the time in GANs, we are concentrating on generative tasks because generatives are creative. So if you think that GAN is creative in terms of generator, I have self-supervised learning. I have creative. Self-supervision is trying to do kind of a learning, right? So I can think of, it could be related, but self-supervised can maybe intersection. That's what I see at least. Maybe you could ask an IIT or an MIT professor, he could paint a bigger picture. All I know is there is some relation. I can't see more than that. My knowledge is also outdated from 2021. I have very little time to upskill as well. The last thing that I attended was New RIPS 2021. That thanks to SAP, it just funded, and because it was online and morning you were doing job and evening you had to attend, so I had to cherry pick only few sessions, so I don't have the bigger picture. Okay, how to efficiently represent uncertainty when we predict missing frames in a video or missing patches in an image? Boss, whoever it is, you can't represent uncertainty, because in the talk I said uncertainty is the biggest barrier for self-supervision. In RL, the learning is reward driven, but SSL learning is self-driven. Can you discuss scenarios where SSL method is most appropriate? Oh, okay. Again, I come to the same example. RL is the cherry. Can you discuss scenario where SSL method is more appropriate? Fine. So self-driven is always better than reward-driven, right? So reward means, for example, you are having an auto person, you're going from place A to place B. You're either looking at different things. Are you looking at time? Are you looking at cost? Or are you looking at comfort? Right? So that is reward driven. But SSL is the way of traveling itself. Right? So that's the scenario. Can you share a few research topics? Okay. Maybe I will give you a, so most of the time in any company, right? You go and say, hey, what is the minutes of meeting? What is minutes of meeting? At ICN, we just flip it. Wow. What is the wow in that meeting? So when you search, you might get one result and you say, wow, that is your research topic that you are looking for. But pick it and try to see for a logical conclusion. Maybe that could be helpful. Okay. Is Robota a self-supervised learning? ROBERTA. Remove RO and A. What is there is BERT. And we know that BERT is self-supervised learning. Are you doing few short learning on text generation tasks? Because NLP to HANA looks like generative tasks. Maybe it's like translation. No, boss, it's more than translation. You're trying to understand the natural language itself, breakdown. You're trying to understand the SQL, which is basically the format itself, trying to understand each of it. Okay, for this, where this, the top, given this, right? It's not translation. Maybe for you, it's looking like translation. For us, it's not. Where is your thought on self-supervised learning being the next big thing break towards AGI? Go and ask thought leaders. This is my first attempt. Okay. Any other questions? How are we doing on time? No open questions. Oh, superb. All the questions are closed. You are super quick. Self-supervised in action, boss. So previously it used to be 50 overs match. Now people are looking into 20-20 match. Please post your questions in QA. Okay, sorry. This is from moderator. Thanks for an awesome session. Thank you. Ricardo Sereno. This is my first attempt. And I am part of the 7, you could call it 7 transformers in the team. I am just a small auto encoder. There are BERTs, there are robotas, there are bigger people in the team. Okay. Thank you so much for my opportunity.